This video is on solving one-step equations by addition or subtraction, and it's lesson 19 in your book. Here's some definitions that we need to know for this lesson. First of all, an equation is a statement that uses an equal sign to show that two quantities are the same. Now, the difference between an equation and an expression is that an equation has an equal sign, whereas an expression does not. A solution for an equation is a value for a variable that would make a statement true. So it's a constant, a number that you can plug in for a variable that will give you a true statement, something like 2 equals 2 or negative 1 equals negative 1. And equivalent equations have the same solution set, meaning you can plug the same number in for the variables in both equations, and they would have the same solution set. So those are equivalent equations. Here we need to identify if the given number is a solution for each of these equations. So here what they're asking for in the first example is x equals 3 a solution to this equation? Or can we plug 3 in for x in this equation and get a true statement? Now the only way to know is to try it. So I'm going to plug 3 in for x. That will give me, instead of x, I write 3 plus 6 equals 9. Now 3 plus 6 I know is 9. So now my statement is 9 equals 9. And since this is a true statement, then x equals 3 is a solution. And I'm going to abbreviate solution SOLN. Okay, now for the second example, we have x minus 6 equals 9 for x equals 3. And we want to know, is 3 a solution for this equation? Or does plugging 3 in for x make this equation true? So I'm going to try it. I'll plug 3 in for x. And then I have minus 6 equals 9. Now if I subtract 3 minus 6, I get a negative 3. So now I have negative 3 equals 9. This is not a true statement. This is a false statement. Negative 3 doesn't equal 9. So here, x equals 3 is not a solution. These are examples, and these both need to be in your notes as examples. Here we have the addition and subtraction properties of equality. The addition property of equality says that you can add the same number to both sides of an equation and the statement will still be true. For example, if we have a statement that says 2 equals 2, that's a true statement. If we add the same number, 3, to both sides, then we get 5 equals 5, which is also a true statement. As long as you do it to both sides of the equation, both sides of the equal sign, then your statement remains true. The subtraction also has a property of equality. So it says the same thing except with subtraction. You can subtract the same number for both sides of an equation and the statement will still be true. So here we have 10 equals 10. That's a true statement. If we subtract the same number, 4, from both sides of the equal sign, we get 6 equals 6, which is another true statement. So as long as you're subtracting or adding the same thing to both sides of the equal sign, you still have a true statement. And we're going to use that to solve some equations. Now, we want to use inverse operations. Inverse operations are operations that undo each other. They're opposite. So addition and subtraction are inverse. If you want to undo addition, you subtract. And if you want to undo subtraction, you add. Multiplication and division are also inverse operations. So if you want to undo multiplication, you divide. And if you want to undo division, you multiply. Here we have an equation, x minus 3 equals 12, and we want to solve this equation. Now, when we say solve this equation, it means that we want to find the value we can plug in for x that will make this a true statement, that will end up with something like 12 equals 12. We can solve equations like this by using opposite operations. Now, I want something that says x equals some number to tell me what I can plug in for x. So I'm essentially trying to get x by itself here. So I want to get rid of everything that's not x on this side. I'm subtracting 3. So to undo my subtracting 3 and make it go away, I can do the opposite operation. The opposite operation of subtraction is addition. So I can add 3. Now if I add 3 to this side of the equal sign, I'm just going to draw a line here because that denotes our sides, I also have to add 3 to this side of the equal sign. Now what I'm left with is x minus 3 and plus 3 cancel out, they become 0, equals 12 plus 3 is 15. So my solution to this equation is x equals 15. Now I can know that I have the right answer, the right solution for this equation, by plugging in the value of the variable to the original equation and seeing if it makes a true statement. So if I take this equation right here, x minus 3 equals 12 that I started with, and I plug in this number that I found as the solution, I should get a true statement. 15 minus 3 equals 12. Well, I know that 15 minus 3 is 12, so now my statement is 12 equals 12. Since that is true, x equals 15 is my solution. You can always check an equation by plugging in your solution to the original equation. Here we've got another equation, negative 15 equals n minus 8. And I want to solve this, which means I want to find the value I can plug in for n that will give me a true statement. Now, what I need to do is get n by itself. So I'm going to draw this line here. Now, here's my n. I want to get rid of everything that's not n, because I want to have n equals something. So I want to get rid of minus 8. So I'll do that by using the opposite operation. This is subtraction. The opposite operation is adding. Now if I add 8 to this right side, then I also have to add 8 to the left side of the equation. And when I simplify, negative 15 plus 8 gives me negative 7. This is still an equal sign, and all I'm left with over here is n, because negative 8 plus 8 is 0, so that would be n plus 0. So my solution is n equals negative 7. Now I can check and make sure it's correct by plugging in that number for n, my original equation. So I've got negative 15 equals n minus 8, that's my original equation, and I want to plug in negative 7 for n. So I have negative 15 equals negative 7 minus 8. Now negative 7 minus 8 is negative 15. So now I have negative 15 equals negative 15. Since that's a true statement, negative 7 for n is the solution. This one's a little different because there's no subtraction in this one. Actually, now there's addition. And I want to solve this equation, k plus 7 equals 13, by using opposite operations. Now, I want to figure out what I can plug in for k that will give me a true statement, something like 13 equals 13. So I have to get this k all by itself. So I'm going to draw my line where my equal sign is. Sorry, that's a really crooked line. Now I want to get rid of this plus 7 so that k is by itself and I have k equals a number. The opposite of addition is subtraction. So I'm going to subtract 7. If I do that to the left side of the equation, I have to do it to the right side. Positive 7 minus 7 gives me 0. So on this side I just have k, or k plus 0. That's still an equal sign. And 13 minus 7 is 6. So the solution I have here is k equals 6. I can check and make sure it's correct by plugging 6 into the original equation for k. So k plus 7 equals 13 is my original equation. I'm going to plug in 6. 6 plus 7 is 13. And 13 equals 13 is a true statement. So k equals 6 is my solution. Here's another one. I have negative 21 equals p plus 9, and I want to find out what number can I plug in for p to make the equation true. So I'm trying to get p by itself here. Now to do that, I have to get rid of the plus 9, so I use the opposite operation. So this is plus, so I'm going to use minus 9. What I do to one side of an equation, I have to do to the other. So I'm going to subtract 9 over here also. Negative 21 minus 9, these are both negative, so I know my answer is going to be negative, and 21 plus 9 is 30. Equals, now here, positive 9 minus 9 is 0, so all we're left with is p. So my solution here is p equals negative 30. I can check it and make sure it's correct by plugging negative 30 into my original equation, which was negative 21 equals p plus 9. So here p equals 30. Oops, that gives me negative 21 equals negative 21, which is a true statement. So my solution here is p equals negative 30. Now before I get even further ahead of you, you should know that this page, the previous example, here and here, those all need to be in your notebook because those are examples, problems that we're doing. And this one needs to be in your notebook also. Here, we have a fraction equation. Now, fractions don't make the equation any different. You still work them out exactly the same way. However, when we add and subtract fractions, we have to have a common denominator. So sometimes it's best to make a common denominator before we even start. Okay, so I have 1/4 and negative 3/8 here. My common denominator is going to be 8. So I'm going to have to multiply the top and bottom of this fraction by 2. So now I have x plus 2/8 equals negative 3/8. Now, to solve this equation, I want to get x by itself because I want to figure out what I can plug in for x to make a true statement. Now that means I'm going to have to subtract 2/8 from both sides. Over here, positive 2/8 and negative 2/8 cancels out, and I'm just left with x equals negative 3/8 minus 2/8. Negative 3 minus 2 gives me negative 5 over 8. Now if I want to check and make sure that's correct, I can plug it in here. Negative 5/8 is x plus positive 2/8 equals negative 3/8. Negative 5 plus 2 is negative 3 over our common denominator. And there's our true statement. So our solution here is x equals negative 5/8. Alright, finally we have another example. This needs to be in your notebook. On January 10th, 1911, the temperature in Rapid City, South Dakota fell 47 degrees in 15 minutes. What was the temperature at 7 a.m.? Okay, so we know it fell 47 degrees from 7 a.m. So we have some temperature that we don't know at 7 a.m. Now, since it's a number that we don't know, we're going to call it x. And since it fell 47 degrees, that means that we subtracted 47 degrees from it. And when that temperature fell 47 degrees, it fell to 8 degrees. So we had some temperature at 7, it fell 47 degrees, and it ended up being 8. Now we have to figure out what that temperature was using opposite operations. So I want to get x by itself. Negative 47, to undo the minus, we want to add. And if I do that to one side of an equation, I have to do it to the other. Over here, my negative and positive 47s cancel, and I'm left with x equals 8 plus 47, which is 55. So at 7 a.m., the temperature was 55 degrees Fahrenheit.